Hello, everyone. I've had a couple of requests to get down some information about momentum bar charts. Either the topic was confusing, you may not have been here for that particular lesson, so this is going to be a quick rundown on momentum bar charts. And I do want to preface this little mini lesson by saying that aside from the assignment that I gave you that directly asks you to draw momentum bar charts, I will never actually force you in any problem, like an actual practical application, some sort of collision, inelastic or otherwise. I will never force you to do a momentum bar chart in order to solve the problem. There are plenty of other ways to go about solving, most of them a little bit faster. So if speed is your game, or if you're, very comfortable with equations, then momentum bar charts may not be particularly useful to you. However, if you're a very visual person, these may be useful. So just follow along here, and hopefully these will make a little bit of sense. So momentum bar charts are used to analyze the momentum of a system before and after changes to the system. Momentum can be distributed between objects, but the total must remain the same. So basically, all of the different types of systems that we're going to analyze in this momentum unit are situations where you start off with some initial conditions, some stuff happens, and then you end up with some final conditions. And most of the time, those final conditions are different than the initial conditions. Let's say if I have two objects moving at a certain speed and they crash together, more often than not, they're not going to be going the same speed after they collide, and we can use momentum to figure that out. And a momentum bar chart is a way for us to visually figure out how to distribute the momentum of a system. Sometimes I use the analogy of Legos. You've got two stacks of Legos, and you treat the system as all of the Legos. They put a box, around those two stacks of Legos. And I can take Legos and take them from one stack and put them on the other, and vice versa, but the total has to remain the same. And that's what we are trying to show visually. So in general, the template for a momentum bar chart looks like this. Note that this is not a normal XY graph. This is not an XY plane. It is, a unique diagram that is used in this particular scenario. So I have some dotted lines and a solid line, or I guess let's just start. I have a solid line down the middle that represents 0. That means any bar above that line is positive, any bar below that line is negative. And we could have either. We could have positive or negative momentum. But the dotted lines indicate a plus sign, and the solid vertical line indicates an equals sign. So in general, everything to the left-hand side of the solid line has to equal everything on the right-hand side of the solid line. And when I say all of, I just mean the sum total. So we figure out how much stuff we have on the left-hand side, and then we look over at the right-hand side and figure out essentially how to make it balance. The goal is to balance the bar chart. In any particular problem, we're going to have a couple of unknown quantities, and we're going to have to, figure some stuff out from there. So let's actually see, or before I go on, I've got on the left-hand side, we're basically only going to deal with two object collisions in this unit. So each of those objects will get its own column, both initial and final. So P1 initial means the momentum of object 1 before the stuff happens. P2 initial is the momentum of object 2 in the before times. And then P1 final and P2 final are the momentum of each object after the stuff happens, whether it be a collision or otherwise. So we're going to apply this in the following way. We'll start here. Two objects are moving in the same direction. Object 1 has a momentum of 10 kilogram meter per second, and object 2 has a momentum of 5 kilogram meter per second. The two objects collide. If, after the collision, object 1 has a momentum of 5 kilogram meter per second, what is the momentum of object 2? So I think it becomes prudent for us to, pretty briefly, just write down the terms that we have so that we have the numbers and the variables right in front of us. So let's read. Object 1 has a momentum of 10 kilogram meter per second. So to me, that says P1 initial is 10. Object 2 has a momentum, that's P2 initial of 5. The two objects collide. So now that's the before stuff. Now we go to the after stuff. After the collision, object 1, P1 final, has a momentum of 5. Then we come up on the question of this problem, which is what is P2 final? What's the momentum of object 2? And we're going to go ahead and draw ourselves a quick chart to illustrate the scenario. So P1 initial, P2 initial, and I made an oops there. That's a final. And I forgot to mention that this column right here is going to remain empty, right? Eventually, we're going to put the impulse in there. Impulse meaning the amount of force that we apply to the system. But for now, we're going to pretend that it is not there. We're not providing any extra oomph to the system. So how do we actually fill this in? Well, we basically go column by column and figure out what needs to go where. And we're going to do our very best to make these bars at the approximate height relative to each other. So P1 initial is 10. I'll go ahead and draw a bar for 10. P2 initial is 5. I'm going to go ahead and draw a bar for 5. This will be 0, nothing in there. And then P1 final, I see, is also 5. So now what? Now my question is, what is P2 final? So that's the question of the day. What is P2 final? Now, what we're going to do here is we're going to use the bar chart to figure out what that unknown quantity is. And we can do that by adding together all of the momentum on the left-hand side and figuring out what we have to do on the right-hand side to make that equal. So the total on the left-hand side is 10 plus 5, or 15. So we need to have 5 plus something to make sure that both sides are equal, right? And this goes back to the Lego analogy. On the left-hand side, I have a stack of 10 Legos and a stack of 5 Legos. Then if I go on the right-hand side, I end up with a stack of 5 Legos and what? Well, of course, the simple answer is that it has to be 10. Okay, so we have to have 5 plus 10 kilometer per second of momentum in order to make that balance. Okay. So we're using the bar chart as a way to visualize balancing these scenarios. Let's move on. Let's do another one. Two objects are heading towards each other and will collide. Object 1 has an initial momentum of 10. Object 2 has an initial momentum of -5. What will be the final momentum of object 2 if object 1 stops after the collision? Interesting. So, notice that we have a negative sign in here, so we're going to try our best to not let that throw us off. No reason to panic. Negative numbers are just as easy to deal with as positive numbers. So I'll write down our numbers. P1 initial is 10. P2 initial is -5. And then object 1 stops after the collision. P1 final equals 0. So P2 final is again our unknown. Now we draw a chart. I'm going to draw this a little bit lower this time. And there we go. So P1 initial, P2 initial, P1 final, P2 final. So now we're just going to have to remember that this is a 0 line, and we're going to see that we can draw bars above and below said line. So P1 initial is going to be a +10. P2 initial is going to be a -5. This is 0. And P1 final, we said it goes stationary, so no velocity, no momentum. So P2 final is our unknown. So what do? Well, we look at the left-hand side, and we can see that we have some positive and some negative momentum. So if we add those together, it hopefully is relatively clear that some of that negative momentum is going to cancel some of that positive momentum. And that's absolutely true. So we can say that 10 plus negative 5 is a total of 5. So I have in total 5 kilometer per second of momentum on the left-hand side. So if I'm going to balance the right-hand side, that means I need a column with 5 kilometer per second right there. So that is how you would balance that particular momentum bar chart. We have a total of 5 on the left and a total of 5 on the right. Even though, if we're looking at the absolute numbers, we have a positive 10 and a negative 5, so it seems like we have a bunch more momentum, right? The negative cancels some of the positive. Okay, one more. Two objects are heading towards each other and will collide. Object 1 has an unknown momentum, and object 2 has an initial momentum of negative 20. If, after the collision, object 1 has a final momentum of 10, and object 2 has a final momentum of 30, what was the initial momentum of object 1? So what this is going to show is that we can actually work in any direction with these. That's no big deal. So P1 initial this time is the unknown, and P2 initial we know, that's negative 20. P1 final is 10, and P2 final is 30. Interesting. So let's go over to our chart and see that we can't figure this out. All right, P1 initial, P2 initial, P1 final, P2 final. All right, so what goes where? P1 initial is our unknown. We'll leave that blank. P2 initial is negative 20. Okay, this column is 0. Again, we'll fill that in with something else later. We will fill that column in when it is present, when something else is present. There isn't any of that thing right now. P1 final is going to be a positive 10, and P2 final is going to be a positive 30. So now we have everything on the right-hand side, and we need to make the left-hand side balance. So how would we do that? Well, we would look at the right-hand side, which is the side that has the most information. We see that we have a positive 10 and a positive 30, giving us a positive 40. And then on the left-hand side, we have a negative 20 and some unknown. So some unknown minus 20 equals 40. And if we calculate what that is, that's a positive 60. So that means, and I'll try to draw that-ish where it should be. That means that that column has to have a value of 60. Okay, so again, looks weird, but that negative 20 is canceling some of the positive 60, giving us a total of 40 on both sides. So that's momentum bar charts. Hopefully that's at least understandable enough for you to go ahead and complete that assignment. If you like them, then absolutely use them by all means. Not so happy with them, that's fine. We've got other methods of solving these problems. So shoot me an email if you have any questions. Otherwise, see you in class.